I'm sorry, I was muted. So again, thank you for joining Azure Innovators Hub. I'm sorry for the difficulties. It's been a long time that we have done a live demo and a live session in our channel and in our group. So again, as I was saying, a lot has changed. The group has been under a transformation for the better. I'm still adjusting on this. I mean, new tools, new software, and trying to have a better quality for the videos and for the live streams. I'm also a little bit more flexible. I am allowed to make mistakes. Not everything will be flawless because it's a live demo, and I have kept a little part of that so we can do that together and live with me, see with me how this is working. So new technology, Project Rayfin, announced on Microsoft Build 2026. It has to do with Fabric. It has to do with the data platform, and it's a very groundbreaking approach on how eventually a data platform and data management or governance or a unified data platform may look like, where data is feeding everything and it's about everything. Companies are pushing vendors, integrators, and partners to create solutions for them in order to understand their data, in order to talk to their data, in order to clean their data and make the data make sense. So a lot of things have been happening around this term, data platform, data engineering, and everything has to do not only with AI but with the maturity that comes after some time. The waves of cloud and AI and modernization have been acknowledged, and now that the dust settles, organizations, enterprises, and decision makers are taking a step back and looking into the technology landscape with a clearer view, a new perspective, a new eye for what they want, what they want to achieve, what they need to do. So we should be ready for this new view and this new perspective where the customer, the enterprise, the organization is a little bit more sure and more deep into what they want. So, Project Rayfin for today. Let's be back in 1 minute. Thank you everyone for joining. I'll be with you in just 1 minute. Thank you. So yes, I'm going to switch off my camera since you don't need to have me on your screen. You just need the information. So let's save on that. right? The project I created for this specific reason is named Impact IQ. The IQ part taken from Fabric IQ and Foundry IQ and everything IQ, but it's a little bit more than that. It's a project that that was about to participate in a hackathon. I didn't have the time to complete this participation. Nevertheless, the project remained. It's a very solid project, a very well structured demonstration. So why not? We are seeing all around this comparison, the old versus the new, this struggle, this fight where the old is trying to stay and the new is trying to take the place of the old methods, the old sequences. And for example, especially into the analytics era and into the analytics landscape, not era, area. We have a structure with the flat and the relational raw tables, the approach being reactive and historical, and the execution mostly manual with complex SQL joins, and a little bit of AI with black box probabilistic guesses. The new paradigm is coming to add some flavor, some color, and some flexibility. Connected semantic graph. The approach is more predictive, proactive. It is consequence driven. It is not event driven. We're not exploring something that happened. We're exploring what will happen and how can we avoid something, plan ahead, and see further than the actual fact or event that caused any type of disruption or change or anomaly or whatever. It's not only about anomalies or disruptions, it's whatever. The key and the decision is up to the organization. So a lot of drivers should be here. And the execution is automated, traversing the ontology of our data. The AI application is deterministic. The reasoning is transparent, and every recommendation coming from the AI is traceable. Nothing is black boxed, everything is transparent, and the AI is smarter and to the point, knows better and does better. What we're exploring here is the following. Assume, let's say, that we have our data that consists of supply and delivery. We have suppliers, we have our products, we are creating, let's say, some type of food or beverages, and our relation with the suppliers is very strong. We need the suppliers to provide materials so we can go ahead and create our products. So the first thing that we notice in the supplier ontology system is the risk. Apart from the ID, we have risk because if we miss the supplier or something goes wrong, we don't have product, right? And this is something that needs to be underlined here and highlighted. Observe this very simple but very important aspect. Supplier equals risk equals product affected, right? So the supplier supplies the product which is stored into our warehouse. Along with the product, we are getting regions where revenue is created. The product generates revenue into the regions. Okay, the warehouse ships the product into different type of shipment status and the ETAs, which in turn serve the regions. Also, the warehouse holds the inventory of the products, the quantity, the daily demand, and the day's coverage. Actually, what we're seeing here, guys, is uh, an X-ray, an ontology in this graph depicted as simple as possible. And now the impact. The impact starts from the supplier in our demonstration. So what is the impact path? The impact path is as follows. If a supplier cannot deliver a product that is affecting the warehouse, which affects the shipment, the region, and at the end of the day, the revenue, this is something important. This is something that needs to be examined in every dimension. Be careful. We are observing a single, let's say, um, a single view, a 2D, a two-dimensional view here, but in reality, imagine how the impact path is multiplying across our data estate for different types of relationships. So the ontology graph is quite more complex, and in turn, the impact path spans across a lot of artifacts, a lot of entities, right? Our product, Impact IQ in our case, our solution, reasons over these connected business entities and this allows us to trace the precise ripple effect of a local outage to systemic revenue exposure. So it's very simple after this explanation to say supplier outage equals a revenue outage. Okay? How a multi-agent architecture can help here, can really offer this factor, uh, this flavor, this capability that will make the change. We're talking about Azure AI Foundry in our case. Of course, the ontology that we saw a little bit earlier and the graph is created on Fabric. We're going to have a deeper view, but for now, we're sticking to the presentation so we can understand what we're talking about. So in Azure AI Foundry, we can have the discovery agent that traverses this Fabric ontology and the graph relationships based on user selection. Okay? The impact agent that calculates deterministic metrics strictly from the affected subgraph and ensures repeatable business reasoning. When we have enough data, enough knowledge, enough correct depiction and mapping of the impact and the analysis, then a recommendation agent will be able to synthesize the facts and then create prioritized mitigations uh, that will transparently explain why and provide actions to solve any issues coming from an outage in our case. How this aligns with our enterprise model. This is a reasoning mechanisms. It is connected. We have connected business entities, right? The ontology map, remember, that allows us to trace the precise ripple effect of a local outage to systemic revenue exposure. So in the enterprise model, we have our data foundation, which is Fabric, Lakehouse, and Warehouse, and the semantic model. The context layer, this is very important and is the source of truth for our automation engines, the AI. It's about the Fabric IQ ontology and the graph. Then we have the orchestration layer, heavily dependent on the context layer and um, the correctness of the context layer, let's say, the reliability of the context layer, and then the deployment layer that comes afterwards. For example, we can have container apps, services that uh, deploy the mitigation, utilize the knowledge from the agents and uses infrastructure in our Azure to create solutions and be this deployment layer. For this specific project, the Impact IQ, we can see that the user injects a theoretical disruption into the live graph to evaluate the downstream consequences. It may seem simplistic, but when you see the actual data and how the ontology is created, how the relationships are mapped, it's not an easy thing to do. So the actual project, the Impact IQ project, it's something that will stay with me and probably will be something that will evolve. For our case, we are creating theoretical disruptions because there is no actual supply chain to apply this theory and this demonstration. So what happens? Let's say that our first supplier or one of our suppliers, Northwind Steel, is having an outage. Whatever outage could that be, from a strike to a disaster to whatever. How the supplier outage affects our revenue. And this is something that we need to estimate correctly at that specific point in time so we can have transparent view and solutioning, right? The ontology and the relationships that we have created are the context for the AI to be able to understand this path, this ripple effect that we have discussed. So if a supplier goes down, we are affected by 15 products that are coming from the supplier, meaning that in 4 warehouses where we store these products, we are having issue, meaning that 6 active shipments waiting to load the products are disrupted, meaning that these shipments were destined for Germany, Austria, and Croatia, for example, are impacted. How this translates to numbers, and here it is, the bottom line metrics. This is what the stakeholder, the business owner, the CEO, the CFO, everyone included into this chain will understand how this little thing, one supplier cannot deliver today. What does this mean? Is this something that we can say, oh, it's okay, we will do it tomorrow? Or it is something that affects our revenue big time? And of course, it is big time. How I came up with these numbers? We are going to have a deeper look into our warehouse, into our lake house in a few. So this translates into a 4.7 million exposure with 14 days inventory coverage days and 82% critical supplier dependency. Okay, of course, these are deterministic metrics, but these are based on actual case studies, real world scenarios. The agentic reasoning and mitigation now is where magic happens. The discovery agent will traverse 6 layers from north to steel with a soft graph isolated. The impact agent will calculate this number, the 4.7 million exposure across 3 regions, and then the recommendation agent will create this analysis and it will say you need to have a backup supplier available. The match is here. The lead time is plus 4 days. And not only one, you need to have 2 level of mitigation, a 2 layer mitigation. Reroute shipment X from alternate warehouse, so you have a 22 mitigation of the whole revenue risk, and action 2, activate your backup supplier. Apex Metals, for example, For product category C, you're not trying to solve everything at once. You are mitigating parts of this effect. You're mitigating parts of the whole chain that went down. And by doing this, you are able to reduce the risk. You are able to put actual numbers into the mitigation engine and provide a better alternative instead of trying to solve everything at once. This is quite important. This is preemptive, and this is what our ontology can do. As an example, of course, with this specific project named Impact IQ. So, context over queries with a Fabric IQ ontology that transforms raw tables into a living business model. Deterministic impact assessment that ensures repeatable, trustworthy business reasoning. Transparent mitigation with multi-agent orchestration that provides actionable recommendations with fully visible reasoning traces. How this is done, how we can do this? Well, this is where we have a lot of inputs here, and the wow factor is quite big. I'm not going to say anything. Allow me to bring my VS Code here. So, the first thing that we want to observe is the actual event, right? We have an ERP, for example, or we have a secondary application or whatever that observes our chain, our supply chain, our deliveries, everything. On top of that, we are able to create this front end that in reality talks to Microsoft Fabric and generates all the data that we need. So let's have a look into Fabric and what's going on. So here it is, a workspace. The workspace consists of our lake house. The lake house has been seeded with different tables representing an actual supplier mechanism. We have dimensions tables, the date, the month, the product, the region, the supplier, and their warehouse. And then we have the fact tables, disruption events, the inventory, the orders, the revenue, and the shipment. Of course, every table has a relationship with another one. We have dimensions and fact tables, and we can see the relationships. But I think it's most important to first of all look into the semantic model with the relationships as well. Okay, this is the model view, and the real magic is when we have the ontology. This is our ontology that provides this very simple but very important reasoning over an effect, not an effect, an incident. Okay, so in order to reach this state of understanding through our software, the ontology is able to do the following. A supplier experiences a disruption event who supplier supplies the product, right? Now, the product is in the middle of this ontology map because the inventory consists of products. You can see here how the ontology is actually created. So the product supplies the supplier supplies the product. You can see the arrows, how they are, uh, where is their rotation. So the product is stored into the warehouse. What's going on with the warehouse? Let's see the ontology here for the warehouse. The warehouse ships shipments. Warehouses are located in regions. Now, I believe that so far you have just understood what it means to create an ontology and why it is important to have a correct ontology. This is something that we are creating manually. Okay? So, for us to be able to provide this intelligence to our agents and to our models, we need to take the time to create our ontology in a way that is analytical, simple, and corresponds to the actual reality, the actual pragmatic uh, flow of our business. Okay, based on this, we are able to generate the first front-end application, which is quite impressive. So we have this mission control. This is the first application that we have. Okay, remember, we are not having multiple events. We are saying just one supplier. Just one supplier goes down. Okay, and the outage is detected because our data is flowing into our lake house. And once an outage is detected, immediately this frontend alerts us with the supplier outage detected message or alert. What is the impact? Let's give it here to analyze it. Let me see why it refuses to provide the impact. This is new. Let me try this. Okay, let's get a minute break and I will fix this. Give me a moment. Okay, never mind. I will proceed to show you the actual backend and the magic that happens in our fabric while this Next.js problem is solved by our copilot. So let's see why it is important, this thing. The Rayfin project, right? Fabric. You are able to create via an SDK, the Rayfin SDK, applications directly into your Fabric environment. Each application has its own URL, so you don't need to log in into the actual Fabric environment, yet you need to log in with Fabric SSO. What does this mean? Let me show you. Here's my application. Okay, let me refresh it and show you here. Open. So you're getting a login screen and you need to log in with your Fabric credentials. Okay, it is not yet able to provide whatever type of authentication you need. You need to have Fabric credentials and you need to be able to log in here. So what's happening again? This application is hosted right into Fabric. We're running it into our Fabric environment using the Rayfin SDK. What we're able to create, we're able to create the Impact IQ control towers as it is called, where you can implement this uh, incident injection. So we have different types of incidents already injected here, and you can, ask the AI about exposure, suppliers, and decisions. This part I left it intentionally out of the equation so we can do it together. The AI is not yet ready, I think. Let me see. No, the AI is ready, my friends. And what is this AI? This is an Azure Container App that is running as a separate um, uh, agent hosted in Azure Container Apps, and it is able to provide answer for us directly into the Fabric environment. And this is the magic of the Rayfin project. Okay, of course, I can reset the demo or rerun an agent that will be able to scan any um, outages from our suppliers. Okay, pick something that has high risk and provide mitigation planning. Okay, here is the decision trails. Of course, since we have only one important incident in my demo, it's always picking the Northwest Steel supplier outage and suggesting the different mitigation strategies that we should be able to have. Of course, we can reset the demo and zero everything here. Let's return to our front end because it was working, and it's a pity that it didn't work the first time, but I think it will work because there is nothing new, nothing changed, to tell you the truth. So let me go back to my front end, and you will see the relation between the front-end application that will be something like an ERP integration or an analytical application that provides high-level detection of outages, especially for, yes, this is the one. Okay, so here we have the front end, let's say, that lives in web apps, container apps, wherever. This is called the Impact IQ, the actual project, the actual product, okay, the mission control. What we have here is a very analytical and uh, very insightful dashboard that provides information about everything that is happening in our supply chain. And by happening, I mean something that will impact our revenue at the end of the day. The The real magic, however, is that everything is analyzed up to the numbers. So something that will happen in our supplier Northwood Steel, it will be translated into revenue exposure, inventory coverage, and active shipments, affected regions, affected warehouses, and affected products. These numbers are correlated to describe the risk level, so it is high. The agent activity is analyzed here, and then we have this beautiful graph that describes the relationship, describes the ontology that I showed you a little bit earlier. You can see how deep you can go to understand how Northwind Steel is affecting our pipeline, our deliveries, and our revenue at the end of the day. Within our Graph Explorer, within our relationship graph, we have our ontology. This is the magic of the new terminology like ontology and IQ and everything. This is what actual Fabric IQ means. Okay? One outage, deeply analyzed up to the numbers regarding what's happening, why it is affected, what is the route that brings um, this risk into our pipeline, into our workflows, and so on. Okay, and then we have your mitigation plan where you can export it into anything, really anything, from an API call that activates an event-driven reaction, another system that you have for auditing reasons, or a simple PDF. The magic, of course, is the Rayfin application where you are able to work with an actual AI system living outside of Rayfin. Rayfin lives inside Fabric. It's better to sit here without the Fabric icons like a standalone application. This is what you're getting as a URL. And let me reset the demo. Everything is zeroed. So you're injecting an incident, shipment delay, and then you run the agent to analyze what's happening. And here it is, your agent bringing data, smart data, why this incident is affecting you, what is the exposure, what's the mitigation. So you have here your AI, not just for chat. You have an AI system that provides real intelligence. Okay, what is our biggest exposure right now? Which supplier is most at risk? Summarize the latest decision. What should be prioritized next? And so on. The agent is thinking, and this is the decision. Okay, really, really important. And let me show you how Rayfin works from the developer perspective. So I'm going to show you everything from the front-end application that makes this beautiful, really beautiful graph, this relationship slash ontology graph with every node being clickable, showing you the relationship from left to right and how this affects your revenue. Okay, nothing is done, is left to its luck, as we say here in Greece. Nothing is left to work or solve on its own. Deep realization of every little incident with categorization and alerting, so we don't get every single little thing like a big alert. Okay, you saw here that Rayfin classifies this as a high risk. Why it is classified as a high risk? Here it is. You have 15 products that's affected, 4 warehouses, 3 regions. The revenue based on this calculation is 4.7 million, with an 11 days inventory coverage and 6 active shipments. It's important. Your supplier outage is affecting you big time. You need mitigation. And how you going to explain your mitigation? Here it is. Here is your graph, your ontology, your IQ. Okay, this is why we it is named IQ, and we're using it as an IQ. And of course, you know, Microsoft does this, invents new terms, which is nice, by the way, but you need to understand why, and this is why. Okay, and this is the evidence from Fabric, so nothing is left in luck. Again, let me return to the developer friendly environment, VS Code. Okay, first of all, the actual Impact IQ frontend with the graph and everything is an Next.js application. I'm going to have it in GitHub very soon, so you will be able to explore how everything is done. It's quite simple, and of course, you can clone it and reuse it, and um, how can I say, optimize it, enrich it with more supplier events, and maybe integrate it into an actual pipeline, an actual workflow. I'm working on this, so probably you're going to see something from the real world and the actual real world in the next months. The Rayfin project. This is the Rayfin SDK. It is developed for the purpose of creating backend applications, not from the strict backend perspective. These are named backend, but they are providing actual user interfaces, as you saw. So actual uh, JavaScript based applications. These are, as you can see. Let me show you the Rayfin. It is a TypeScript language. The Rayfin SDK has everything you need in the GitHub repository, not so much into Microsoft documentation, rather into GitHub, so you can quickly plug in your Copilot, your Claude, or your whatever assistant and help you quickly bring up a small demo. Once you understand what you can do with Rayfin and the Rayfin SDK, the sky is the limit. This project was created for the purpose of showcasing Rayfin, but it is turning out to be an actual project that will be utilized most likely for a similar type of cases with incident mitigation and monitoring. Again, you need to be proactive and build your Fabric data platform in a way that the intelligence layer is efficient and is uh, is a return of investment, to tell you the truth. Okay, the ontology as a term is not working by its own. It needs your inputs and your way of thinking and understanding the business and the cases in order to bring this IQ layer into the fabric. It doesn't generate IQ out of thin air. It generates IQ from the relationships and the ontologies that you create. Okay, so stay tuned. I'm sorry for the small interruption, but everything is happening for a reason. It was nothing. It was the caching thing with the next app. So it was something really nothing to worry about. One more, I will show you once more the front end, which is the mission control, observed by your business analyst, even in a mobile application, you can have only the relationship graph or whatever it is. It is something that you can build on mobile. You just need to work a little bit on it. You can get this screen dedicated, so you can have the relationship map for every incident, for every incident. So you have your proof here, okay? You have your proof, your evidence. Why an supplier incident is affecting our revenue. We have all the evidence, all the IQ, all the explanations. This is the front end. And then you go back to your Rayfin application and you are actually taking decisions. With some help with your agent, you are getting your decisions quickly. Activate your backup supplier, right? Or whatever else you can activate. I think in our presentation, we had two solutions for this case. Yeah, reroute shipment. Reroute your shipment from alternate warehouse B. So your warehouse B may have more products from the specific supplier. So reroute your deliveries for the next 3 days from warehouse B in order to keep your main warehouse still filled with products until the outage of the supplier is resolved. Now, take a step back, remove the the supplier from the fact that it is actually supplying something, right? And bring this over the industries. That means electricity, energy, whatever, communications, food, and goods. It is something that applies everywhere, guys. Okay, this is very fresh. This is very new. It was just announced in Build 2026. Project Rayfin for your Fabric data platform. Intelligence goes hand by hand with your backend applications. Uh, Feel free to ping me and connect with me in order to take this to the next level. I will do it because I have started and now I can stop. This is really important for Fabric, and it will position Fabric in as a leader into intelligence data platforms. It's not just a data platform; it's the intelligence layer over everything that's happening with your data in your organization. Okay, now I'm not having any questions or actual live chat. Thank you for being here, whether you are watching this live or you're watching the recorded version. I'm Konstantinos from Azure Innovators Hub. Many thanks. Have a great day, afternoon, or night. See you, everyone. Take care and yeah, be safe.